So let's talk about electrostatics. Electrostatics is the study of stationary charges, right? Electro means electric charges, electricity, and statics means stationary. The electrostatics is the study of stationary charges, the charges which do not move. You have heard something about frictional electricity already, right? So in frictional electricity, you sometimes experience a static charge. For example, if you are wearing a nylon clothes, then if you remove them, or while removing them, they will stuck to each other and even your body also, right? So it is because of the static electricity, the charges. Sometimes when you walk and on the carpet and open the door, the metal knob will give you a little electric shock. Okay, that is also an example of static electricity. Now these electric charges were not at all understood in 18th century, right? So in the beginning of the 18th century, one person named Benjamin Franklin, he did some experiments. He found out that rubbing the bodies will create some attraction between the two bodies, right? So he said that if one body is rubbed on another body, right, then it attracts the other bodies after separation. Now what would have happened here is that there may have been a exchange of some fluid. Okay, for example, the negative fluid came from this body and enter in this body, and it lost the negative fluid, so it became positive, right? He said overall this negative fluid and positive fluid are in equal amount in any given body. So if this negative fluid gets excess, then it becomes negatively charged. If it positive fluid becomes excess, then it will become positive charge, right? So in a neutral body, these two fluids are in equal amounts. Okay, so that was the first consideration, that the electric fluid is present, and as a result there is, but later it was found out there is no such a thing as electric fluid, right? These are the charges. Benjamin Franklin also experimented with a kite, where he flew the kite in the thunderstorm and was able to collect the charges in a jar which is kept on a ground. Okay, so he was the first pioneer in this field of electrostatics, right? Okay, now there are two types of charges. One is positive charge and another is negative charge, right? This charge plus or minus, what does it mean? You cannot define that like this, right? You cannot define a mass in a fundamental manner. It is a fundamental property of the matter. Similarly, charge is also a fundamental property of a matter, right? And any charge, if it is present, then a mass is always associated with that. It is not, there is never a massless charge. Any charge, if it is there on a body, then that body has a mass 100%, right? It will have a mass. Now there are two types of charges, plus and minus. Now in the 20th century, people found out that this is a positive charge, and around this positive charge there are electrons flowing in an atom's model, right? This is a nucleus and this is the electron which is revolving around this small nucleus. They named it positive, they named it negative. These negative charges, that is the electrons, are actually getting transferred when you rub the bodies, right? Okay, so now why I call this positive, why not this one as positive, why not this one negative? The answer to that is very difficult, because it is a convention. You could as well have called this charge as negative and this as positive, but it doesn't affect the physics of that. Okay, we ended up with this notion that this is positive, this is negative. But yes, the positive negative will attract each other. The two unlike charges will attract each other, while two like charges will repel each other, right? So let's look at the properties of charges in detail. The first property is that charge has always a mass associated with it. Always a mass associated with it. Okay, if there is a charge, then that means it is the mass is actually there. Okay, so you cannot have a zero mass and a non-zero charge, right? Second, like charges repel like charges repel, that is positive will repel, negative will also repel, and unlike charges attract, and unlike charges attract. Like charges repel while unlike charges attract. And the third property is that charge is quantized. Charge is quantized. What do I mean by quantized? See, if you have a charge q, right, then it is always an integral multiple of some fundamental charge. For example, you know ATM, right? From ATM you can take out a cash. So you can always take out the money in the multiples of 100. You can take 500, 400, 300, so on, 700. But you cannot take out 750 rupees out of ATM because it is not a multiple of 100. So all the time you will take out the money, it should be in the multiple of 100, integral multiple, right? Integral multiple, that is integer times the 100. You cannot take, for example, 585 rupees, right, from ATM. You have to take 600. So this charge is quantized, and that means it is an integral multiple where n is an integer times e, right? N can be 1, 2, 3 and so on. But it is always an integer. It is not 1.5, 3.5 like that, or 1 by 3. And this E is a charge on an electron. Charge on an electron. So before I talk about charge on an electron, let me talk about this Q. Q is the total amount of charge. Okay, it is the total amount of charge that I am talking about. Total amount of charge. The SI unit of charge is Coulomb. SI unit of charge is Coulomb. This is the SI unit, named after a scientist named Coulomb, right? And that is capital C. Now Q is n times E, integral multiple. This is an integer. Now charge on an electron is how much? The charge on an electron, one electron charge is minus 1.6 into 10 raised to minus 19 Coulomb, right? How did they get this number? We will see in the modern physics, right? In a Millikan's experiment. He did an experiment to find out the charge on a electron. So this is 1.6 into 10 raised to minus 19. So all the charge in this universe is the multiple of this number. If it is a positive number, then it is plus here, right? So you can also write here as plus for the negative, because this is minus 1 point, no? Or minus if the charge is positive. Okay, this is the integral multiple, fundamental charge, right? The fourth property is the charge, amount of charge is always conserved. That means you can neither create nor destroy the charge. Let me write that here. It's very important property. This was actually told by Benjamin Franklin, that you can never produce a charge or you can never destroy a charge. A charge can neither be created nor be destroyed. Can neither be created nor be destroyed. Okay, it was given by Benjamin Franklin. That means if you have a universe like this, okay, if you have a universe like this, these are the boundaries of the universe where you cannot take out the charge from, out from or in from. Okay, you cannot take away charge from this boundary away, or you cannot take in charge from this boundary. So here if initially there was plus 3 Coulomb charge, right, and after that I found out there is one charge minus 2 Coulomb, one charge plus 1 Coulomb, then there will be definitely 4 Coulomb charge somewhere here. Okay, so 4 minus 2 will be 2, 2 plus 1 will be 3. So initial charge is same as the final charge. Okay, so you cannot create a charge out of blue, right? You cannot create a positive charge. If you are creating positive charge, means somewhere else a negative charge simultaneously is being created, so that you cannot overall have created a charge, right? Okay, so these are the properties of the charges.